Let's talk about powers of the imaginary unit I. Everything that I discuss in this video is based on the fact that the square root of -1, although not a real number, can be represented with an I. I stands for the imaginary unit, and it's been created by mathematicians to simply represent the non-real number, the square root of -1, when it appears in a problem. So a square root and a square are inverse operations. For example, the square root of 9 is 3, and 3 squared, because a square and a square root are inverse operations, takes you back to 9. Using that same property, if the square root of -1 is represented with an I to the second power then would be back to -1. So I squared is -1. Let's talk about the next power of I to the third. Well, I to the third could be broken apart into two factors, I to the second times I. And since we just discussed that I to the second is -1, if I replace this I to the second in this product with a -1, I see that I to the third is equal to -1 times I, or more simply, -I. So if you ever run into an I to the third in a problem, that can be replaced with -I. How about I to the fourth? Well, I to the fourth could be broken apart as I squared times I squared. And we know that I squared is -1, so I to the fourth is -1 times -1, or simply 1. If you ever encounter an I to the fourth power in a problem, that can be replaced with a 1. Now this pattern repeats itself for powers greater than 4 on I. Let's discuss how that's done. If we already know that I to the second is -1, I to the third is -I, and I to the fourth is exactly +1, this is actually enough information to determine a simplification for I to any power. Because, let's go from the bottom up. Any I to any power, which is a multiple of 4, is equal to 1. So I to the 8th is exactly 1. I to the 12th is exactly 1. I to any power that is exactly a multiple of 4, like 40, is actually equivalent to the real number 1. I to the third is equal to -I, and 3 is 1 less than a multiple of 4. And in fact, I to any power which is 1 less than a multiple of 4 can be simplified to -I. So I to the third power is -I, but so is I to any power that is 1 less than a multiple of 4, like 7. 8 is a multiple of 4, so 7, 1 less than a multiple of 4, simplifies to -I. I to the 12th is equal to 1 because 12 is a multiple of 4. A power 1 less than 12, 11. This is a number that is 1 less. This is a power that is 1 less than a multiple of 4. So this is -I, just like I to the third. I to the 40th, 40 is a multiple of 4, so that was equal to 1. How about I to a power 1 less than that, like I to the 39th? That simplifies to -I. This pattern continues. I to the second equals -1. 2 is 2 less than a multiple of 4. And you know what? I to any power that is 2 less than a multiple of 4 also simplifies to -1. So I to the 8th was 1, because 8 is a multiple of 4. 2 less than that multiple of 4 would be I to the 6th. That simplifies to -1. Another multiple of 4 is 12. If I take I to 2 less than 12, 10, that simplifies to the real number -1. I to the 40th was equal to 1 because 40 is a multiple of 4. How about 2 less than that? I to the 38th. That simplifies to, you guessed it, -1. Just like any power on I that is 2 less than a multiple of 4. And finally, I to the first, I to the power of 1, or just I, that's 3 less than a multiple of 4. And I to any power, which is 3 less than a multiple of 4, simplifies to I to the first power, or just I. So earlier I said that I to the 8th, 8 being a multiple of 4, is equal to 1. 3 less than 8 would be 5, and that's equal to I. I to any power that is 3 less than a multiple of 4 simplifies to just I. I to the 12th, earlier I discussed that that equals 1 because 12 is a multiple of 4. 3 less than 12 is 9. I to the 9th simplifies to just I. I to any power that is 3 less than a multiple of 4 is equal to I. Finally, I to the 40th power was equal to 1 because 40 is a multiple of 4. How about 3 less than that? I to the 37th. That's going to simplify to I. This pattern exists for I to any power. You can use these properties to determine a simplification for I to any power, and we'll do that on a few examples right now. The first example we'll look at is I to the 70th power. When you're trying to simplify I to a power, think about or ask yourself this question: is 70 a multiple of 4? Because if 70 is a multiple of 4, this would simplify to exactly positive 1. But 70 is not a power of 4, so the next question you'll ask yourself is, what is the first number greater than 70 that is a multiple of 4? And that would be 72. 72 is a multiple of 4, and based on the pattern we just discussed, that means I to the 72nd power would simplify to exactly 1. And remember, an I to a power that is 1 less than a multiple of 4 is negative I, and I to a power that is 2 less than a multiple of 4, like the I to the 70th we're dealing with in this example, is equal to negative 1. I to the 70th simplifies to the real number, negative 1. How about I to the 47th power? Again, we'll ask ourselves, is 47 a multiple of 4? It is not. The next question, what is the next number bigger than 47 that is a multiple of 4? Well, that's 48. 48 is a multiple of 4, so I to the 48th would be positive 1, and I to the 47th, because 47 is 1 less than a multiple of 4, is negative I. I to the 47th, same thing as negative I. Let's do one more. How about I to the 101st power? Well, again, I'll ask the same two questions. First, is 101 a multiple of 4? And that answer is no. So this does not simplify to 1. What is the next number bigger than 101 that is a multiple of 4? And that answer would be 104. So I to the 104th power would simplify to 1. I to the 103rd power, this is a number 1 less than a multiple of 4, would simplify to negative I. I to the 102 power, this is a power that is 2 less than a multiple of 4. That would simplify to the real number, negative 1. And then 101 turns out to be a number that is 3 less than a multiple of 4. I to any power that is 3 less than a multiple of 4, like 101, simplifies to just I. So I to the 101st power simplifies to I.